Hey guys, today our topic is pharmacodynamics, or at least part 1. By the end of this video, you should be able to define the concept of a drug, define pharmacodynamics, list the types of receptors and their known function, understand the principles of drug-receptor interactions, and apply the concept of dose-response relationships to clinical scenarios. The Food and Drug Administration defines a drug as a substance used in diagnosis or as a component of medication. Now, let's get into it. Today's topic is on pharmacodynamics. What is this? Pharmacodynamics is concerned about the effect of a drug at its site of action, the dose-response relationship of the drug, and the influence of other factors on the drug effects. Drugs have various targets of action. These include receptors, enzymes, DNA, ion pumps, and carrier molecules. The most important context of this video is the effect that the drug has on receptors. What are receptors? Receptors are like the little sensors of your body and are responsible for coordinating various systems that take place in your body. Drugs can act on these receptors and effect changes in the body. Receptors are protein components of the organism that binds the drug and initiates this effect. We have two types of receptors, intracellular and extracellular receptors. Nuclear receptors are intracellular receptors, and as the name suggests, these receptors are found in the nucleus of the cell. When acted upon by certain chemicals, they carry out gene transcription. Now, recall that transcription is responsible for protein synthesis. Proteins made would include enzymes and hormones that exert several effects on the body. Now, think for a second. What substance do you think could pass the cell membrane and enter the nucleus of a cell? You guessed right. Substances that are highly lipophilic. These include your steroid hormones such as estrogen or testosterone, which are made from cholesterol. Under extracellular receptors, we have the following. There are G protein coupled receptors. Now, these receptors are the most abundant in your body. These G proteins contain 3 subunits, the alpha, beta, and gamma subunit.